substitution in my videos, and I had given a basic idea of what it actually is. But to elaborate more on substitution, the most interesting tool we're going to be using in grade school level integration, I am making this video. So I'm basically going to answer a few questions that might arise in your mind while using substitution. For example, the first question is, when do we substitute in integration? When do we substitute? This is the first question. And it has a very simple answer. So there is this generalized formula, and you might be able to relate to this formula for whenever you had used substitution. So this is the formula. When we have a function of x to the power of n, where n is any real number, and it is multiplied with the differentiation of the same function of x, that's when we use substitution. When we have an integral like this, is exactly the place to use substitution. Substitution is the easiest and the only method to solve integrals of this kind. The second question which might arise in your mind is, why do we differentiate when we use substitution? Why do we differentiate when we use substitution? And this has a very simple answer as well. So one of the basic rules of integration is that suppose we have a function of x, we have to integrate a function of x. So the basic rule is that we can have any multiple of x in this place, any constant added or subtracted to x. It doesn't matter. But the only variable which should be present inside the integral should be x. Should be this variable over here in general. So if we say take another variable, say t, so we should just have a function of t within the integral. We can have unknown constants, that won't matter. But we cannot have another variable inside the integral except for the one which the integral asks for. We cannot have any other. We cannot have any other variable except for the one mentioned right here. Let me take an example to make it more clear. So the example is the integration of x divided by x squared plus 1 to dx. This is the integration that we're going to perform now. You might already know what I'm going to do. That's right, I'm going to differentiate x squared plus 1. I'm going to substitute it. And so let me do it in another color. X squared plus 1 is equal to t. So when we differentiate both sides, this is what we get. You might have a clear idea of the explanation, from the explanation which I gave you right now, as to why we differentiate when we use substitution. I just differentiated both sides so that I can get the numerator over here, which is x, in terms of t. As we see, we have x dx is equal to dt divided by 2. So we have the entire numerator. We have the entire numerator in terms of t. So we are ready to substitute from x to t. Because as I said, we cannot have two variables in the same integral. We cannot integrate two variables at the same time. So this is the integration of this. So we have dt by 2. So dt divided by 2, and x squared plus 1 is t. Since 2 is a constant, we can bring it out. We can write it like this. We can bring it out of the integral. And the answer, therefore, is half log t plus c. So if we did not remove the x dx, if we just kept this as t, it wouldn't make any sense. We still wouldn't be able to integrate this because t is equal to x squared plus 1, x squared plus 1 is equal to t. That wouldn't make any sense. And therefore we differentiate this so that we can replace the numerator as well in this case. The numerator in this case as well. And we can get it in terms of t. That is the substitution variable. And thus substitute it and find the answer. The final answer, we simply replace t with the value that we substituted t for. That we put t in place of in the original integral. So this is why we differentiate when we use substitution, to maintain uniformity and to avoid confusion. I hope you've understood why and when to use substitution. Actually, why to use substitution? Because in these cases, there is hardly any other way to solve without substituting, any simpler way to solve without substituting. There might be a few other methods, but the simplest one is substitution, definitely. So whenever we find this case arising, so this n can be a negative integer since it's a real number. N is a real number, so it can literally be any number. So when we have a generalized formula, when you see this appearing in any of the questions that you come across, you can just simply substitute and make your way out of the problem very easily. So yeah, that's it for this video. Thanks for watching.